Good morning, this is Ms. Billerbeck, and we're going to talk about volume of figures. So what is the volume of figures? So of a cube with a side of 4 meters. So we know that with a cube, we want to draw a picture, and a cube is just basically a 3-dimensional square. All the sides are the same length. Okay, so if we have that, we have 4 meters here, 4 meters here, and 4 meters here. So the volume of a rectangular prism or a cuboid or a cube is length times width times height. So on this one, we have the length here, the width here, and the height is here. So the volume then is, we have meters, so it's 4 meters times 4 meters times 4 meters. So in fact, it's just 4 meters cubed, which is where this word cube comes from. Okay, so when we do 4 meters cubed, that's 16 times 4, which is 64 meters cubed. Okay, so with volume, our dimensions are cubed because it's 3-dimensional. If you can pour water into it, it's 3-dimensional. We talked about area before, and their units were 2-dimensional, so everything was squared. But volume, everything is 3-dimensional. All right, let's talk about the volume of a cuboid with a width of 7, a length of 4, and a height of 2. So we have a length of 7, a height, or let's see, a width of, it's a width of 7 and a length of 4. Okay, so we're going to make this a little shorter. So our width is 7 and our length is 4, and then our height is just 2. So we have 2 inches here. We have a width of 7 inches and a length of 4 inches. All right, so let's go ahead and draw that 3-dimensional figure. Okay, so it's always a great idea to draw out what you're trying to solve. So now we know we have a length of this, a width of this, and a height of this. So our volume then is 4 inches times 7 inches times 2 inches. So the volume ends up 4 times 7 is 28. 28 times 2 is 56. Or we could have seen 4 times 2 is 8, and 8 times 7 is 56. We're using the commutative law of multiplication. So we have 56 inches cubed because we're talking about volume. All right, let's look at another example of volume. So what is the volume of a rectangular prism with a base of 9 feet, a depth of 4 feet, and a height of 10 feet? So these are different words that mean something that we've already been doing. So the base is 9 feet, and we can abbreviate feet as FT. Okay, the depth, how deep does that go, is 4 feet. And then the height is 10 feet. So this won't be to scale or even close to it. So let's go ahead and draw that. Okay, but it helps to always draw. Okay, so it might be easier to draw this one just flat across like that. There you go. And when you practice drawing, you get better and better at it. Okay, so this was the base, but the base can also be the length. Okay, and the depth can also be the width. And the height is just the height. Okay, so volume, we had base times height, or base times height times depth is another way you could have looked at it. Okay, but basically it's just the same thing, where let's do base times depth times height, so it's not confusing. Base times depth times height. So if people use different words to say these things, it really means the same thing. So I just want you to be familiar with different ways of saying things. Like rectangular prism is the same thing as a cuboid, okay? So the volume then is the length is 9 feet. The width is 4 feet. And the height is 10 feet. So when we multiply this out, we get the volume is 36 feet squared. And then when we multiply by 10 feet, all we have to do for that multiplication is to add a 0 to this. So it's 360 feet cubed. So whenever we multiply by 10, we just add that 0 to what number we are making a product with. Okay, so the volume of this rectangular prism, which is also a cuboid, is 360 feet cubed. So make sure you keep those units, okay? If it doesn't say units, you use units cubed. Okay, but when we deal with objects, they have dimensions, so we need to make sure they also have units. So what is the volume of the cuboid shown? Okay, if each one of these blocks right here is 1 meter cubed, okay, so this is actually supposed to be the same thing as that. So maybe I should make that just a little narrower. So that looks like, no, that's about right. It just looks different. Okay, so anyway, this is 1 meter cubed. Well, you could just count them, couldn't you? You could just say 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And then notice that there's a whole set back row there. So that means there's 12 times 2, which is 24. So then you would have known just by counting that we have 24 meters cubed right there. Or you could have said, oh, there's 2 meters here. There are 4 meters here. And there are 3 meters here. Okay, so then the volume then is 3 meters times 2 meters times 4 meters, which is 3 times 2 is 6, 6 times 4 is 24 meters cubed. Okay, so again, if you were at a loss and you forgot this formula, volume is length times width times height, you could have gone to your streetwise or math-wise strategies and said, hey, I can just count. If these are 1, I can just count up the cubes. Okay, so that works too. Okay, there's so many ways to solve every problem. So you just have to be resourceful and have a lot of tools. Okay, sometimes we get complex shapes like this. This is called a complex shape. Okay, so it means it's a combination of shapes. So if we look at this shape, we have a couple different shapes we could be dealing with. We could say, oh, we have a shape like this that has a big chunk bitten out of it. Or we could have said, oh, hey, we have two different blocks on top of each other. So there's two ways we could have gone about finding the volume of the total complex shape. So if we were to do it with a big volume minus this volume, we could do that, but we first have to find some missing pieces. So in engineering, when we draw a figure like this, we cannot double dimension. When we double dimension, it causes a bunch of problems because let's say we decide that, oh, that length needs to be 10 thousandths longer. So we fix the length on one thing here, but it's double dimensioned, so we don't forget, we might forget to change it in the second area. So with engineering, we never double dimension. So that's why you see so few dimensions on these figures. It's because you can find them, okay? So if this length is 10 and this length is 5, what is 10 minus 5? So this length is 10 minus 5, which happens to be 5 meters. So 5 plus 5 equals 10. So we wouldn't write this because that's considered double dimensioning. Right, in the same way, this length is 14 and this is 9. So 14 minus 9 gives us 5 meters here as well. So 5 plus 9 is 14. Okay, also we know that this is 8 meters here, and this is also 8 meters here. So all these lines in the depth are all the same. You have 8 meters here, 8 meters here. So they're all the same. All right, now that we have doubled and tripled and quadrupled dimensions, now let's figure out what we have here for volume. So the volume of the big shape, we're going to do that. So we have the length is 10 meters. The depth or width is 8 meters. And the height is 14 meters. Okay, so we have the volume big is going to be, it's always easier to add the 10 at the end, but we can go ahead and do this. Okay, so 10 times 8 is 80 meters squared times 14 meters. Okay, so we have a 0. 8 times 4 is 32, carry a 3. 8 times 1 is 8 plus 3 is 11. So we have 1,120 meters cubed for the big one. Now let's look at this little one that we are volume little. Okay, so that one we have 5 meters times 8 meters times 5 meters for the height right here. Okay, so this is 5 meters right there. So our volume of our little one that's not there is 5 times 8 is 40. 40 times 5 is 200 meters cubed. So the volume of the shape then is V big minus V little. So our volume of our shape ends up being, our big one was 1120 meters cubed minus 200 meters cubed, which ends up being 920 meters cubed. Okay. Well, we could have done that differently. Okay, so let's look at how we could have done that differently. So if I had done this cube here and this cube here and added them. So let's try that. So let's do volume of the bottom. So I'll do volume bottom, like that is going to be 10 meters times 9 meters, and or 8 meters for the width, and then times 9 meters. So that gives us 720 meters cubed, because 8 times 9 is 72, and then times 10 is 720. Now this little one here, so the volume of the little, or let's say top. So the volume of the top is 5 meters times 8 meters times 5 meters again. So we have 5 meters, 8 meters, and 5 meters. Oops, it's this one. 5 meters across, 8 meters here, and then this one here is 5. So 5 meters. So this happens to be 5 times 8 is 40 times 5 is 200 meters cubed. Okay, so now we can just add the two of them together, this block plus this block. So we add them together and we get 920 meters cubed, which is exactly what we found before. Okay, so in both cases, we found 920 meters cubed. So we did it in two different ways. Okay, so there's a lot of math strategies we can use. So there's not just one way to do things. Sometimes we might want to force you to use one way just so you learn the skill, but we also want you to have many tools so that you are resourceful and know how to find the answer to your mathematical problems. On that note, I hope you have a wonderful day. Bye-bye.